Every machine, from your vacuum cleaner to your car, is made up of a series of parts. Those parts are designed by specialised companies who first build a prototype, then make tools needed to manufacture the parts. 3D design of the chosen parts are created in a computer, which then guides the machines that construct the prototype. The 3D drawing is divided into cross-sectional layers just a few thousandths of a centimetre thick. A laser is programmed, then directed at a tray filled with a light-sensitive liquid resin. The laser's light hardens the resin into the shape of the part, layer by layer, eventually constructing the prototype. The prototype is rotated under an ultraviolet light to cure the resin. Then it's polished or painted according to the design requirements. Another prototyping method works much the same way, but uses a fine powdered plastic instead of resin. The computer guides the laser to melt the powder in the shape of the part, again, layer by layer. The hardened prototype is extracted from the unmelted powder. Yet another method doesn't use a laser at all. The computer simply guides machinery to carve the prototype out of a hard material, such as wood. Once a prototype is ready, it's used to construct a model of the part out of a durable resin. This model will create a mould, which will be used to make a metal cast. Channels are attached that will guide the molten metal into the mould. Next, they fill the model with a mix of sand and binding agents. The surface is numbered for its tracking purposes. The sand mix takes about 15 minutes to harden into a mould. Now the part can be finely cast. Magnesium, heated to 700 degrees Celsius, is poured, then the spout blocked to prevent the metal from reacting with air. The metal takes about 10 to 20 minutes to harden, after which a vibrating conveyor breaks the mould apart. A plaster mould is used to cast parts that require a better surface finish. The mould goes into an oven to cure at 300 degrees Celsius for up to 72 hours. But it's not ready for casting just yet. Workers first have to pierce air holes. If they didn't, the metal wouldn't flow into all the crevices. Filters are also secured to keep out impurities. Workers pour in molten magnesium. Again, they seal the opening with sand. It takes the metal anywhere from 20 minutes to an hour to cool. Then the plaster is broken to reveal the metal part. The channels through which the metal was poured are cut off, and the piece is finished off by the sanders. Finally, special spray paint that adheres to magnesium is sprayed on, and the part is finally finished. When you think about it, even the machines that make these parts are made of parts that were made like this. It's a never-ending circle.